My son is riding a 250 Yamaha with motard wheels on the racetrack, and it was time for the small service, as you can see, in the middle of everything. And just to make sure Dad was properly occupied, he successfully transferred such a conrod bearing into something like this. One of the biggest problems with the Hälsaberg, especially the engine between 01 and 07, I believe, was that the main bearings don't last very long. And all kinds of bearings have been tested, in both ball bearings and roller bearings and such. None is really putting up enough effort to do the job. And the culprit is the crankshaft itself, because it's bending too much. During its operation, the ends will tumble like this, and a normal ball bearing is absolutely not satisfied with such a treatment. In my engine, these normal ball bearings last about 5 to 6 operating hours. So I really had a lot of problems with that during the season 2015. So I decided to do something about it. We have done a lot of simulation on the whole crankshaft, seeing how big the forces are and how much it is bending. And we have been trying to figure out what is the main culprit, what can be done to make the crankshaft more sturdy. We have ruled out that the width of the web could be one thing. We thought that it is not possible for it to hold the crank pin in place. That wasn't really the issue, even if we in the model added material around the crank to make it this distance, the press fit, longer. It didn't help very much. We tried to, in the model, make the crank pin larger. That didn't have a very good effect either. But one thing I think is definitely making things worse in this application is the placing of the counterbalancer, because it puts out the main bearing another 12 millimeters away from the web. Normally the main bearings are fitted close to the webs on either side. So that is one thing. And but when revving as long as I do, it will be a problem for the bearing nevertheless. So, but a friend of mine in Australia, hello Bushy, has tried these types of bearings. It's a spherical roller bearing, and it has the great feature that it is possible to have a misalignment of about 1.5 degrees, also a tumbling effect of 1.5 degrees. And also due to the width of this bearing, it takes a large radial load. It cannot take so much axial load, so I will have to grind the inner ring a little bit on this bearing to make it slide on the shaft. But these bearings are 20 millimeters wide in comparison to the normal ones, the ball bearings. So I need to put some to make some space for it. It has the same outer and inner diameter, but the width is too large. So I will throw this counterbalancer away. Other people have done it successfully, and install in Here in the right side I will put a sleeve, a steel sleeve like this with a small edge to fit down here in this place, and on the other side there will be a nut securing it in actual position, and here you have the position for the sealing gasket. And on the left side, I will put such a sleeve in, and it will move out this side's main bearing, so it will be positioned directly close to the crank web. And also there is a large flange here. I will try to put some bolts here to secure this in actual position, and that's only because when the heat goes up, the aluminum will expand much more than the steel will, so there is a potential risk for this to lose the press fit. That's why I want to secure it with lock nuts. So keep your fingers crossed. We'll see what this can do. Preparing a set of cases for racing is just not like that. For instance, I have put in Carillo rods. They are 145 millimeters tall instead of 135. The reason for that is it's another discussion. But anyways, this rod will go very tight onto this surface here, and this area here is really thin. So I have to add a little bit of material and grind it smooth again, so there will be a sealing edge still. And the reason for that is to maintain the pressure in the crankcase, forcing out the oil through the reed valve to the oil sump, which is in this engine situated in the left transmission case. So there we have some space for the conrod, and still hopefully some material left on the inside to make this a good sealing surface anyway. This is the right hand side case with the steel liner for the main bearing installed. This is how the steel liner looks from the outside. As I'm not using the flywheel anymore, I have no problems with space or for this steel sleeve. Sometimes when cutting threads, it's difficult to get the tap to fit straight into the hole, but it's a whole different thing if you got it in a machine like this. It's much easier, and but you cannot really just take it in slow RPMs and just force it through. That's not the way to go. You will either break the tap or wear it out, or whatever nasty stuff that can happen. So I usually do like this. I line it up so I know it will fit into the hole I've just drilled, and then I'll put it in gear and stop it, and then put it down, and then the tap will engage, and then I can remove the chuck and make it by hand. So I put it in gear and I stop it, and it makes a couple of turns. I loosen the shock, and then I know it is properly aligned for me to turn it manually afterwards. I know there are spherical roller bearings as main bearings now, but being able to do this is downright disturbing. Ugh.